when it comes to electrical installations, the switches, especially the connection here, matters a lot. When you are using a specific cable, do you tighten these screws? And when it comes to these my top bosses, this is what is referred to as a double pole. Your connections must be very, very tight. Other appliances that can draw a lot of current are a heater, so this one is a cooker unit. A heater is connected here. If it draws a lot of power, it will affect the working of a light circuit. Top bosses, it is time for us to now talk further when it comes to these installations. In many cases, you find that a DP is connected in the consumer unit. This is a DP MCP, and if it is loose, and especially on the neutral, there will be an issue. It also finds its application, my top boss, here at the meter box. So we have one that is right here. If there's a loose connection, my top boss is here, it means that it will also affect the operation in the house. Top bosses, if you're ready for this stream, hit that like button. And if you have ever experienced this issue where the customer complains of dimming of lights, let me know in the comment section or in the chats, my top bosses. Now, moving on, we find that this, which is a cooker unit, may also be connected, and you find that there is a lot of dimming that is happening on this LED right here. That dimming basically indicates that there is an issue when it comes to the flow of current. Remember, for circuit to be complete, there needs to be a flow of current from the line or from the face and to the appliance, and then back to the source, which is the transformer, through the neutral line. Top bosses, if that circuit is not complete, if the loop is compromised, it means that there is some losses that are happening somewhere. Where could these losses be happening from? We are going to discuss exactly that. But a loose neutral, my top bosses, can lead to something else that we are about to discuss right now, which is referred to as a surge. Top bosses, if you are ready for that value, then hit that like button, and let us keep on engaging on the chat. Also, if you'll be watching this video as a repeat version, let me know where you are streaming us from, my top bosses, and let us learn a lot. I have a lot of top bosses that watch us from Nigeria. Nigeria, I know, is in the building. I have a lot of top bosses in Uganda, in Ghana, my top bosses who watch us all the way from Zambia. UK is represented in the building, my top bosses. Let me know where you are streaming from, and I will really, really appreciate your feedback. Now, my top bosses, we have these cables, and we also have this important connection right here. I don't know whether it is closer to the camera. So this is what is referred to as a neutral bar. In many cases, it is connected or it is located in the distribution board. Majority of the people make a mistake whereby while connecting the neutrals here for their circuit, specific circuits, they are not very keen in tightening this neutral bar. And that is where the surge comes in. Did you know that apart from a surge that comes from the national grid or externally from Kenya Power for our case here, what is the company that supplies power in your country, my top bosses? In Uganda, do we refer to it as umeme? Yeah. So if there is a surge that comes from outside, we know that we can definitely combat that by having these. What is the name of this product here? Of course, it's from that company, but my top boss, what is the name of this device? In many cases, you might have it in the meter board, or you may connect it in the consumer unit, or basically in the distribution board. What is the name? So if you have this, which is definitely a very important part of a circuit, you will combat any issues surges that come from the national distribution system, the national transmission system, right? So any surges coming from the grid will definitely be combated by this one. But now, my top boss, in case there is a surge internally, in many cases you find that it is occasioned by a loose connection at this point here. A neutral, especially which is loose, and this loose connection is on the mains that are coming from the circuit, you find that it will definitely cause a loose connection. And that is what we are trying to avoid right here. So what is a loose connection? Find that when you are tightening the cable, it is not completely tight. Yeah, even if you try to twist it, it is almost coming off. So that will lead to an under voltage. An under voltage will lead to either flickering of lights, or it will lead to dimming of lights. In many cases, your customer will call you and say, you know what, whenever I activated a cooker, when a, I activated let's say an electric kettle or an instant shower, I experienced dimming of lights. Some bulbs were, flickering, almost going off. But the moment that I switched the cooker off, the moment I switched the instant shower head off, that problem disappeared. Now, when the customer says that as an electrician, just know, number one, there could be a loose connection. So the first target is definitely on the main switches, and your target should be on the neutral. If there's a loose neutral, a loose connection somewhere, just know that that could be the reason. All right. All right. So top bosses, if you're finding value already, hit that like button, and also let me know from the beginning, like we said, what are some of the encounters that you have encountered with your customer, especially when it comes to this subject. Is it flickering of lights, or is it a loose, or is it dimming of the lights? How did you resolve it, top bosses? Tasaidia la pili hapo, ina flow vizuri. Top bosses, where are you streaming from? Where are you watching from? So at this point, we have agreed that any loose connection, and especially you find that if the lighting has a loose connection here, all right, the moment you activate any heavy load, it could be even a washing machine in that home, you find that there will be an issue. All right, the moment that washing machine is activated, then you find that it draws a lot of current. Thank you. That current definitely goes a long way to affect the operation of the lighting, right? So if the lighting is affected, you find that in many cases, the homeowner is not at peace, with everything, because again, you even if you are in the customer's shoes, you will not feel that great, because the customer will you will definitely be frustrated because of that issue, right? Yes. So thank you so much, my top bosses who have already tuned in. Thank you so much for those who are already engaging in our chats. Extremely important. And also, I really appreciate you who says where you are streaming us from. All right, good to see Linjoro, good to see Daniel Kibwage from Kisi. Kenya is in the building. I forgot it. How could I forget Kenya? Kenya is watching us, and I really do appreciate you, my top bosses. Glad to have you streaming this live with us. So this definitely, we have agreed that there has to be tight connections here. In many cases, you find that a loose connection at the switch, especially for lights, you find that does not necessarily occasion or lead to dimming of that light, because at the switch, in many cases you find that the switch has the common connection, where you feed the mains from the consumer unit, And whenever you connect it at the common, the output is also a line which is connected to the lights, all right, or that bulb. So you find that that does not have anything to do with a dim light. But the issue comes in on the neutral, because that is the return path to the source, or basically to the transformer. The moment the return path is compromised, my top boss, then you will have a lot of issues. Now, in many cases, I ask the technicians to do this simple task here, and many of them are finding a challenge. Take your digital multimeter, right? And then place it at the AC voltage, and especially for 720, at least for people who are here in Kenya, whereby we know that the expected voltage for AC is definitely 230 to 240. Anything way beyond that, like 270, that could lead to a surge. Anything way below 200 volts, my top bosses, that is considered as an under voltage. For instance, 190, 180, sometimes even 100 volts, AC. Here in Kenya, where we use 240 volts, that is definitely considered an under voltage. That is an under voltage. So ensure that the voltage, first of all, to begin with, and let me just say this, the voltage drop. I don't know whether we have a bulb here. A bulb could really help us explain something, one or two, three things. Mm. Probably in that bag right there. Mm. As our director is getting us a bulb, we can really demonstrate something. Just one bulb here. So my top boss, this is a bulb. Okay, thank you. A bulb. So we also have something. Whenever you connect a bulb to a bulb holder, these, you see these points here, they are always connected to a bulb holder, and there are pins that are connected on this part here, my top boss. So the pins that are in contact with the bulb right there, my top bosses, are actually where we are supposed to place our probes. So these are probes, or digital multimeter probes, or multimeter probes, right? So when you see my screen indicating that, what does it mean? That battery sign right there, or symbol. What does that mean, my top boss? Let me know in the chats for the smart, yeah, and the fastest boy in the building. Let me know if you are aware what that definitely means. What does John need to do? When it comes to that, my top bosses. Yeah. So once you take your digital multimeter, you take your probes and ensure that it is on 750. Why 750? In our previous video where we were talking about electrical troubleshooting using a digital multimeter, we were able to discuss all that. We agreed that whenever you turn that pointer to something that is wrong and then you use your probes, you will risk losing your digital multimeter. But why say so? Simply because when you are testing for AC and then you place your probe on DC, my top bosses, yeah, and then you ensure, and then you use your probes, yeah, when it is on DC, and then you are measuring uh, AC using your probes, definitely you risk um, damaging your multimeter. So now let me just connect a cable here and then demonstrate to you what I mean by having voltage that is uh, optimal, or the expected voltage. So I will use this clamp meter because my meter, the digital multimeter, had an issue of under voltage, yes, on the battery. So the battery is not charged. I'll make sure that I resolve that, top bosses. So if I connect that, I have my clamp meter. I also can record the voltage. So for both DC, that is DC, if I want to record DC, can simply press and then record AC. Now, using that cable, the white cable, my director can assist me, the white cable right there. Yes. the white cable right there. Okay, so I will use this white cable, and then I will tap power so that we can actually record voltages. And then once we record the voltage, that will be a very simple way of demonstrating how to test for voltages. All right, so using this is referred to as a WAGO connector. WAGO, yeah. For our top bosses here in Africa or in Kenya, we'll use WAGO, but for our top bosses in UK, we'll use a WAGO. In UK, this finds its application. A WAGO connector finds its application, makes things very easy when connecting your electrical uh, terminations, so that instead of just twisting cables, twisting wires, you can simply use a WAGO connector. These are levers that are located in a WAGO connector. We will connect the green one at the center because we have the yellow there. But something else that I would want us to note, my top bosses, is that for you to use a WAGO connector, there is something that you need to note right here. So you need to measure how to actually connect it. So the cable that is allowed, to enter inside, you need to measure it like that. Anything excessive, you cut. But upon stripping the cable, that is what you do. So we previously did. So instead of just cutting, yeah, first of all, we can actually repeat the entire process. So this is the cable that we want to connect to the WAGO connector. How do you use the WAGO? If you wanted to connect it, you first of all cut so that you can actually uh, strip so that we can connect right here. So always ensure that all of them are on the same level, my top bosses, right? So are they on the same level, or should we levelize everything, cut everything so that it is on the same level, and then we'll strip. Now here is where the trick is, my top bosses. You don't you don't just strip for the WAGO. What you do using this WAGO connector, my top bosses, one important thing to note is this point here. So we will place our cable right here, right? And then strip from here, from this point to this point, So to simply demonstrate, I will do that. I'll do that. And that is the point that I will strip from. So I will place the cable right here, and then I must ensure that I strip at that point, right? So that is the maximum length that I should actually strip. So using my cable stripper, right, will also be very careful on that point. So carefully ensuring that I do the right thing while stripping. Okay, so we have our wires exposed. These are referred to as stranded wires or stranded conductors. This is what we refer to as a solid conductor. You see, it is only one solid conductor. These are stranded because there are many, so these are different strands. That is the difference basically between stranded wire and a solid wire, right? Moving on, my top boss, for the blue one, we'll still do the same using the WAGO. These are not by accident on that WAGO or WAGO, so we'll simply repeat the process. That is the maximum length of wire or the insulation that we are supposed to actually strip, right? So this is how to use a cable stripper. Strip it like so, right? And then last but not least, repeating the same, my top bosses. Looks like a tedious work, but again, it is worth it. For pros who want to do it very fast, you can simply uh, compare with a cable that you've already stripped, and then that is definitely your point for stripping. And then you do the same, you strip it, and then that is what we have. I really do appreciate top bosses who come back to say thank you for their lessons, and especially those who have completed school and they have already benefited. I am always grateful. So what you notice is that once we insert the wire inside the WAGO, my top bosses, that is not the, the maximum point. We can still insert it further, and then we can return that lever. So we are sure that it is actually clipping on the wires and not the insulation. Very tight, but a very important point to note is that the wire is totally or completely inside, so it does not short circuit the other. The center one, definitely my top boss, is the earth connection, and we have the green and yellow wire, and then clip the lever as well. Last but not least, my top bosses is the brown cable. Insert it as well. It goes all the way in, clip it, and what you see is that even if you try to remove them, it will be difficult. So that is a tight connection. Now we want to prove that they are not short-circuiting themselves inside the WAGO connector. So what do? We simply test end to end. So so this is partly a lesson where you will learn a lot of using a digital multimeter. So here I'm also using a multimeter or a clamp meter to test for continuity. So if I bring, I want to test for continuity, so you simply turn this knob here for that continuity test. How do you know it is continuity test? The moment you bring the probes together in contact, there's that beeping sound. So if we test between the terminals, it should give us open, no beeping sound, meaning there is no connection between the wires. But if we were to test uh, continuity for the wire, all the way from this plug. So here, this is N, that is the blue. Blue goes all the way to N. So I don't know whether you can hear that sound, but again on the screen, what you can see is actually indicating the, you can say, the resistance of the wire, right? And then if we go to earthing, so it is the center one, the yellow one, and this long pin, the same is repeated. And finally, last but not least, L, which we connected the brown cable, all right? So we'll simply insert that there. And then here, there is a beeping sound. I don't know whether it is audible. Connected the brown cable, right? Terrible. So audible. Awesome. So once we connect it, there is that beeping sound, my top bosses. So it means that there is no short circuit between the terminals. And another important thing is that there is continuity from these pins or these terminals all the way to the end part here. Now, the moment of truth comes in when we want to test the voltage at this point. Will it be an over voltage that we will get, or will it be an under voltage? Most importantly is, what are we expecting? Again, for this clamp meter, we will simply shift from continuity all the way to voltage test. And that is how we do it. We have simply flipped or turned it. And so you can see there is a V with some wave there. So the wave simply indicates, yeah, the wave simply indicates AC, and then the straight line with a dotted line simply indicates DC. But since we are not interested in DC, we are interested in AC, and that is why we are there. So now, my top bosses, that being said and done, we will actually connect, right? Uh, we can connect the probes right there. and right there. And then I will switch on the socket carefully, uh, being very careful not to short circuit myself and injure myself. What do we get on the screen? Is it visible? 200. Oh, damn. 220, 200 to 30, right? Yeah. Awesome. So that is the voltage that we are getting. All right. So if my top bosses, you go to your customer and there is an issue of an under voltage, in many cases you find that that voltage, especially for us here in Kenya, it will not be 239 or 240. Even if you were to get 220, 230, that is okay. That is not considered an under voltage. It is within the range of the voltage that we do expect, because again the system can operate with 220, 230, 240, sometimes even 250, but not way beyond that. If you get 300 volts, that is definitely a recipe for disaster, as we normally say here at Top Heights, because that can lead to what we refer to as a surge. All right, thank you so much for the top bosses who are already live streaming, watching with us. Majority of you I can see. Appreciate that. So what you need to do, my top bosses, in case of an under voltage, you actually need to watch out. What are some of the factors that can lead to that? Dimming of lights is contributed by an under voltage. Now, you start at the consumer unit. At the consumer unit, my top bosses, we have agreed that you target the main switch or the DPMCB. All right, and your main focus should be first on these terminations. If you take the screwdriver first, before we go to the screwdriver, you take your digital multimeter and then you go to the cables that are incoming mains feeding the double pole MCB. Do they feed at the top or is it at the bottom part of the DPMCB? Top bosses, let me know in the comment section. Another important thing, if you are streaming with us, let me know on the chats. Do we feed the mains on the bottom part of the DPMCB or is it at the top? Top bosses, look at that. Look, what will you be testing? You'll be testing for voltage, and that is what we refer to as a VD, right? Or a voltage drop. So what is the voltage drop at this point? Or what is the potential difference? Potential difference is basically voltage, right? Determined by this. So even if you are in America, Canada, you expect the voltage drop to be 100 or 120 because their system is 110, 120. You expect that. If it is anything way below 100 or way below 80, what is the voltage? Yeah. Mm-hmm. The MCB feeds from the top. The MCB feeds from the top. So that is the mains. Oh, thank you so much for that. Thank you, Michael. Appreciated that. You feed from the top and then you tap on at the bottom so that you can feed the loads. All right. Incredible. Who else has a different answer and also an explanation? If I was to ask you, Michael, why? Give you a reason. Why? Because you know, when it comes to engineering, you don't just give answers and run away. You have to give explanations. Right. Top bosses, another important aspect as we are discussing is that you need to subscribe to our channel if you have not subscribed. Yeah. Subscribe to our channel if you haven't subscribed so that you get more of these tips, so that when you go to your customer to troubleshoot, it becomes so easy for you as an electrician. Yeah. So when you get to that consumer unit and you have used your digital multimeter, you test for the voltage, the potential difference across the terminals. Now, if you still get an under voltage at that point, it means that there could be a loose connection at the double pole, so you tighten. Sometimes you even remove that main cable, you know, especially the neutral. You remove the neutral, but again, make sure that for all your troubleshooting, power is switched off, especially at the double port. But you will ask me, John, how do you switch it off and yet you are testing for the voltage? Yes, you switch it off so that you can isolate the loads, and then the incoming line, all right, you can isolate it, because remember, always isolate the neutral after you have isolated the line. And that is why even for these, they come in a manner that you cannot disconnect only the line and leave the neutral, or isolate the neutral only and leave the line. Even for this case here, you find that the neutral is always connected all the time. The only one that you can isolate is the line. Because if you isolate the neutral in the presence of a line, you will create something that is referred to as a surge, and especially if that system is connected to a load. Assuming there is a motor that is running, and that motor is drawing a lot of current from the system, let's say 100 amperes. Is that too much? Not for people used to larger systems, especially industrial or commercial. But let's just flow with my example. If it is drawing 80 to 100 amperes, and then you instantly disconnect the neutral while the line is still on, that motor is a heavy load, will definitely cause a surge internally. That surge will lead to blowing up of other appliances. Even that motor does not stand a chance under that circumstance. Now, once you have isolated the loads, now you can carry out your test. In many cases, I have encountered that the neutral terminal is actually burning, melting these plastics. Sometimes you can even ask your customer, have you experienced a burning smell from the consumer unit or in your house? Or do you hear some sounds, some sounds coming from the consumer unit? If they tell you yes, then you already have a clue. Now, what you need to do, my top boss, is to ensure that you disconnect that power completely, especially at the meter box. Remove the mains cable. If they are charred or charred, or no, let me stop joking. If they are charred, or if they have some oxidation on that wire. So you find that this is copper, but there is some substance, green substance, some rusty substance on the cable, as well as on this terminal here. It is time to do some cleaning, some maintenance, or do away with the entire double pole switch, especially if it has started melting the plastic around it. Once you do away with it, you can prepare your cable, you can strip the cable. Don't add a joint, because that is a mains cable, unless the joint is very, very perfect. So you can disconnect it. And then another important thing, my top boss, is to ensure that once you have replaced with something different, for instance, you can remove this and then you can add, or you can replace with this one. So this one was a new one, and I went to fit it to a customer who is a know-it-all, and they forced me to remove it because they were really chaotic. So if you replace with a one that is working, terminals are very, very clean, it is a new one. And then the next thing that you need to do, my top boss, is to tighten the screws. Tighten and ensure that everything is well. And then take your digital multimeter also and ensure that it is at AC voltages, right? Once it is at AC, now test for the voltage. The voltage, as we said, we expect for our region is 230. Now, you need to confirm with your region. What is the voltage that you expect? Are you in the UK? Yeah. Are you in USA? Ensure that you confirm. Once you confirm that, my top boss, then is it within the range? Once it is within the range, then you are good to go. So once we test for that, now you can switch on that DPMCB, and then test for the voltage again. Connect the loads progressively. What do I mean progressively? connect the sockets, connect the fridge, ensure that everything is running properly, switch on the lights, and then switch off the heavy loads, switch them on back again, and see whether there is a problem. Sometimes it can even persist. The customer may think that, you are lying. So you can also go further and check the meter box. Check the meter box. If there is a issue here, you can repeat the same. If there is a double pole in the meter box, if there are any loose connection, ensure that you tighten all the connections. For instance, here I can see that there are some loose terminations here. I don't know which student was doing that. Ensure that everything is tightened. Once it is tight, then check in the customer's house. You must be able to confirm that indeed everything is working properly. The bulbs are not dimming. When the heavy loads are turned on, they are not affecting the lights. For instance, the heaters, when they are turned on, the lights are still operating optimally. Top bosses, that is it for today. Let me know if you have a question. If you have anything to add, let me know on the comment section. If you'll be watching this video as a repeat version or a recorded version, also on the chats before we go, top bosses, let me know if you have any point to add, and I will really do appreciate that. Mhm. Top bosses, another important thing that I forgot to mention is that if the customer is far away from the source, the transformer, they will always have these issues. So we must ensure that the customer is within the acceptable range. In our case, we are normally told in the radius of 600 meters from the supply or the source, which is the transformer. So, yes, do you have any question?
Yes, from Michael Sagara.
Yeah.
He is asking question, why do we feed the MCB from the top and the reverse?
Oh, from the top? He's the same one who answered,
Yeah.
fed from the top. Uh, okay, allow me to do more research on that, and then I will come back with the question. But in many cases, you find that the brands, it depends with the brands and the design of the consumer unit or the distribution board, as well as how the feed system. By the feed system, I mean there's a bar, the connecting bar between the MCBs as well as the double pole MCB. But I will be able to come with a conclusive answer in the next video. Keep watching our content, my top boss, and I will clarify that. Funza installation of downlights and ceiling lights. Okay, we'll be doing that. We'll also be talking about uh, panel lights. Uh, panel lights. Nowadays, we don't do snake lights. We do the panel lighting. We do the downlighters, and we can also be doing the chandeliers. So we'll be talking about that, my top boss. I will be taking you through step by step on how to install that, how to also use smart switches, yeah, two-way switches, switches that can be controlled remotely from a phone, for a smart home system. All right. Thank you so much, my top boss, for tuning into our today's exciting episode. I think you also found it exciting as well, because it was exciting to me. But always check for that. If the customer is complaining about that, those are basically what you need to be checking on. Once the specific lighting points have been checked, you check the consumer, you also check on the meter box. Apart from that, other external factors, my top bosses, remember, like we were learning in school, external factors, other external factors that could be beyond your control is definitely a long distance from the source, which is the transformer, loose connections also on the neutral's power line, or even the drop cable could be having a joint or a loose connection. So those are factors to consider. Another important thing as a technician is to ask the customer whether the neighbors are experiencing the same. If neighbors experience under voltages or dimming of lights whenever heavy appliances are switched on, then there could be a problem from the mains of that region.
Which meter is better than talking meters or the previous old ones or the previous ones?
Mm. So basically, for me, I would go with the new ones, especially the smart meters. Again, when it comes to consumption, it all depends on how you use your appliances at home. But when it comes to the tariffs, because that is one thing that matters, yeah, it is also again on the consumption. Convenience wise, I would go for smart meters because you don't need to engage the power company to come and resolve your issues, especially when you have been disconnected from the power. All right. Daniel is asking when I will teach about that. We'll be giving you updates, especially on our YouTube channel. But can we talk about that next in the for the ceiling lights, Daniel? That one we will do that when we get a site, an active site that requires that installation, so that we can actually talk about different switches. We'll be talking about different switches apart from these manually operated. We'll talk about smart switches. We'll talk about the touch switches, and yeah, we'll be giving you updates. Make sure that you follow us across all the social media platforms: Facebook, TikTok, Instagram, all other platforms, and we'll be glad to engage with you further. Thank you so much, my top bosses, for tuning in. It has been a great honor to be with you. My name is John Gatehi, and this is Top Lights Electricals and Solar. Goodbye for now.